Hello, welcome to chemistry. I'm your host, Mr. Hicks, and today we're going to be looking at naming ionic compounds. In this video presentation, what we aim for you to be able to do is to take the formula of an ionic compound, like NaCl here, and change it into its name, sodium chloride. So, as I said, there are different options for these cations and anions that are out there, and we need to make some decisions along the way. And so what I'm going to do is I'm going to do this using what I call a flow chart. So with this flow chart, I'm going to look at the anions first. You can see here, it's not overly complicated. Basically, I just need to check out the formula for the anion, find it on my list, and then write down whatever name it is. Cations, however, you can tell are a little bit different, because with the cations, we may take a look at what the cation is, check out what that first element is, and then we're going to go and check our list. When you check the list to see what the name of that element is, you need to ask yourself, is there a Roman numeral sitting next to this name? If there is no Roman numeral, then we're just going to write what the element's name is that you see on the chart. However, if there is a Roman numeral, then that means that there's more than one charge that that particular cation can be. So since there's more than one charge, we're going to have to figure out what charge is it. Once we determine what that particular charge is on that cation, then we can write down the element's name with the appropriate Roman numeral. So let's try a few examples here. I've got our flow chart sitting here, my first example here, and I'll be walking through the flow chart on these so that we can see what to do with them. So the first one, again, the first thing that you want to do is you want to just focus in on just whatever that first element is. Let's just take a look at that first element right there. So I'm going to cover that up. I'm going to see a K. I'm going to go to my list, find its name, and I see that it is called potassium. Potassium, it's a group 1 metal. It only has one charge. So next to its name, it does not have a Roman numeral. So I'm just going to write the name of that particular element. And then I'm going to take a look at the remaining elements. So now I'm going to cover up the potassium and look to see what's left. And it's just a Br that's sitting there. So I'm going to scan down through my list. I'm looking for something with a Br, and I'm looking in the anions list. And there it is. It's a halogen. And since it is just a single monoatomic ion, meaning there's just one element here, just the bromine, then I know that this is going to end with the IDE ending on it. So it's going to be bromide. Again, the first thing I'm going to do is just cover up this second element just so I can look at the first one. Now you see Na with this 2 down here. Now sometimes students get confused because they see the 2 there, and so they're looking all over the chart looking for Na2. You're not going to find that. The reason that 2 is there is because we need 2 of those sodiums with their +1 charge to cancel out the sulfur's -2 charge. So really this is just a single sodium cation, but I need 2 of them in my crystal lattice in order to balance out the charges. So the name of this, since sodium is a group 1 metal, it doesn't have any other charge, so there's no Roman numeral that's sitting next to its name. I'm just going to use the element's name itself, sodium. And then switching over, going to look at what's left over, just an S. And again, I'm going to go check my list and find it in there. And again, it's a monoatomic anion, which means only one element. So it's going to end in IDE. And I find it on my list, and it says sulfide. IDE on the end. Again, cover everything up except for that first element. Find it on your chart. Is there a Roman numeral next to it? Nope, there isn't. It's a group 2 element. Only has one charge. So therefore, we're just going to use the element's name, magnesium. And then we're going to cover up the magnesium and look at what's left. SO4. This is one of those polyatomics that I was talking about. See, I have sulfur and oxygen with it. Sulfur and oxygen with it. And so we need to look down the list, and we're looking for SO4. But SO4, you'll find it on your sheet, that is sulfate. And notice that it has an ATE instead of an IDE this time. That's because it's a polyatomic ion. It has sulfur and oxygen in it. And cover up that first element, everything but that first element. And I see this one is copper. So as I look on the list for copper, I notice that this is one of my first transition elements. Copper has more than one charge. This might be copper 1. This might be copper 2. I'm going to have to decide. Has a Roman numeral, has more than one charge. I'm going to need to determine what that charge is. So we're going to have to check out our anion here. And I see it's a monoatomic anion. Again, don't be fooled by this 2 down here and go looking through your chart looking for Cl2. This is just Cl. And I need 2 of them. So that's why there are 2 of them listed. So as I look at it, I see chlorine has a charge of -1. So this ion that's being represented as Cl2 is Cl2, or excuse me, chlorine with a negative charge, and then I have 2 of those. To go along with the copper. So if I have 2 negative chlorines, and I know that the charge has to balance out to be 0, this copper here must be a +2 charge. So just like before, we figured out with crisscross how many chlorines we were going to need to balance out this charge. Now we know how many chlorines we have, and we need to reverse that process to figure out what the charge was that was being balanced. So I can see that this copper must be a +2 charge in order to cancel out the 2 negative ones from the chlorines. So now that I know what the charge is, now I can write the element's name with its Roman numeral indicating its charge. So this would be copper 2 chloride. I'll give you a little time for this one. Okay, how'd you do? Did you find iron? Hopefully you saw that iron had a Roman numeral with it. It's a transition metal. It could be either +2 or +3. So we need to kind of figure out what it is. So I'm going to look at the anions. And I see my anion over here is OH. I look around on the list to find that, and I found that its name is hydroxide. But more importantly, I found that hydroxide has a -1 charge. So since I needed 3 of these hydroxides with their -1 charges, the iron must be a +3 charge. So this is iron 3 hydroxide. I got a couple more for you. Okay, wonder how you did. So, with this first one that I have here, these are all pretty tricky. This is cobalt. Sometimes people mix this up with like carbons and oxygens, but you got to watch for uppercase, lowercase, right? So uppercase C, lowercase O, that's cobalt. And here's nitrate. I see nitrates in parentheses here, NO3. And I noticed that cobalt is a transition metal. So it's going to have more than one charge. Well, nitrate's a -1. So if I have 2 -1s here, then my cobalt must be a +2 to cancel it out. So this is cobalt 2 nitrate. Our next one there has silver in it. Silver is an unusual transition metal. Tends to only make a +1 charge, so many times we don't write what the charge is. I have seen some authors put down what the charge is along with it, probably just because it's a transition element. So anyways, I tend to do it without the charge. So I'm going to write what this is. This is just silver. Only has one charge. It's +1. And then next to it is chromate. You'll find it in your list, CrO4, chromate. And then finally, our last one here, probably the trickiest one of them all. The first one is manganese. That is a transition element, so it has a charge, more than one charge. And in this case, I need to figure out what the charge is so I can include my Roman numeral. So I need to jump to my anion. And when I search around in my anion list, I find PO4, and I see that that is phosphate. More importantly, I see that it has a -3 charge. So that phosphate with its -3 charge means that the manganese must be a +3 charge, because I only have one phosphate. How do I know I don't have more than one phosphate? How do I know it's not PO and I have 4 of them? Well, I don't have any parentheses around it, do I? So that's just one PO4. It has a -3 charge. So the manganese must have a +3 charge. So the answer for this one then is manganese 3 phosphate. Ooh, that was a toughie. Well, I hope you're feeling more comfortable and able to do this. Grab some more practice if you can somewhere. And if you need to, go back and review some things some more. I know that was a little bit complicated. And good luck with your chemistry.